In the last couple classes, we talked about how to solve systems of equations through graphing. And just to remind you guys again, what a system of equation is a system of equation is just the spot where the point on a graph where two different lines meet. And so we can the way we did it with the graph was just by using slope intercept form and graphing it that way and finding the spot where they meet. We're now going to do we're going to solve these by using actual math or some algebra to figure it out. So in this case, problem number one here is what's the solution of the system? Use substitution. So we're given two equations: y equals 3x and x plus y equals negative 32. Um, Neither one of them is, well, one of them is in slope intercept form, but the other one's not. But that's not a big deal. So let's see how we go about doing this. Well, there's a lot of complicated stuff here. It looks complicated, but it's not. But they're saying in step one, because we know that y is equal to 3x, we can substitute that 3x for y in the other equation, right? So if we know that y is equal to 3x, we can then put 3x right here because we know that y is equal to 3x. We can do that. And then when we do that, then we're only going to have x's in here, and we can solve for what x is. So if we plug in 3x for y, which is what we have here, and we know, I'm going to repeat it a couple times because it may not make sense right away. But x plus y with 3x being substituted for y, again, because we know that y is equal to 3x, equal to 32. We can combine x and 3x to get 4x. And I know that 4x is equal to negative 32, and if that's the case, we can divide both sides by 4, or just ask yourself what number times 4 is 32, or what number times 4 is negative 32. It's negative 8. And because we now know that x is equal to negative 8, we can go back into our original problem that we used at the beginning, original equation, y equals 3x. And if I know that x is negative 8, I can just substitute negative 8 in for x. And if that's the case, y is equal to 3 times negative 8, which is negative 24. And so I know that x is negative 8, y is negative 24. And again, we're looking for the point on the graph, the spot, right? The ordered pair where they cross each other. And without even looking at the graphs, I can then now know that these two equations meet at negative 8 comma negative 24. And if that's the case, we can just double check. Remember we showed this? I showed you guys how to do this. Once we graphed it and found the point that you can plug those values back in and just to check and see if they work in both. If they work in both of them, then you know you've found the solution to it. And so if we know that y equals 3x, and we said that y is 24, right? And we said that x is negative 8, is it true that negative 24 is equal to 3 times negative 8? Yeah, because they're both negative 24. And in this equation over here, we know that x is negative 8, y is negative 24. And is it true that negative 8 plus negative 24 is negative 32? It is. Okay, so this is the first example of using substitution to find the solution. So here's a got it problem for you guys to try. And again, this is the spot where you should pause it. You should do the work on paper. And what I'm going to be looking for on Monday, or whenever the next time is that we meet in class, this is what you should bring with you, is your work on this. So what is the solution to this system? Use substitution to answer your question. So it's a good time to pause it and give them a shot. Do it on paper and give it a try. We'll see what happens. Well, here's some answer choices. And hopefully whatever you got is close to one of these. And the correct answer here is negative 8 comma negative 9. Let's look at the solution, how we went about solving this thing. So we knew that y was equal to 2x plus 7, and also y is equal to x minus 1. So what we can do is we can write the second equation, and then we can substitute the first equation for y. So see how over here we said that y was equal to 2x plus 7? I just substituted 2x plus 7 for this y, and that's how we got to here. And once we're there, look, all we have left are x's, and we can solve for x. So if I subtract x from both sides, I'm left with x plus 7 equals -1. And then we can subtract 7 from both sides, and I get x is equal to -8. And once we're at that point, once we have either the x or the y, we can just come back and plug that x into here or here. Either way, it will tell us what the y is equal to. And so if we plug it in for here, we get -8 minus 1 is -9. And so we know the solution is -8, -9, or at least we think it is. And then we can come back and we can substitute -8 in for x, -9 in for y, and check our work. It works in this case. And again, we substitute -8 in for here, -9 in for the y here, and we check our work. And it should be good.